tossing a coin 4 times. So heads and tails are equally likely. Okay, probability. So that means it's a fraction, right? Number of favorable over the total number. So let's go for the total number first. So if I'm tossing a coin 4 times, each of the tosses has 2 options, heads or tail. So 2 to the 4th, or 16 will be the denominator. Okay, what's the probability of at most 1 head? So I've got the situation with no heads, and so that would be one way to do that, right? So it's all tail, 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 right? Or 1 head. So how many different ways can I get 1 head? Well, I could get the head on the first toss, or the head on the second toss, or the head on the third toss, or the head on the 4th toss. So there's 4 ways to do this, right? So 5 out of 16 total. All right, list the number, find the number, counting the number of pins with 4 symbols that have either a letter or a number with at least 1 repeat. So this uses that concept to find them find the ways to count all the pins and take away no repeats. So all of the ways of 4 pins with letters and numbers is 36 to the 4th, and I'm going to subtract off no repeats. So that means for the 4 digits, I'm taking away 1 every time. Okay, so I've got 56 consecutive integers, and I want if the largest of 56 consecutive integers is 279, and I want to subtract off 56, and then if I add 1, that gets me to the smallest number, which turns out to be 24, right? Using that idea to find out the number in between them is subtract them and add 1. All right, here we go. Number of 3 distinct digit integers, 1, 2, 3, that are larger than 200 and are even, and we're only using these numbers. Okay, so let me put this down a little further. So if they're even, I have to have a special number in the last digit, right? So I'm going to put the 4 here, or I'll put the 2 here, right? So I've got 1 choice for there, 1 choice for there. So those are the only even numbers in this batch. Okay, so they've got to be, so that takes care of the even. Now I want to make sure I go to the first digit, because that's going to make sure that it stays larger than 200. So if I put the 4 here, then what do I have left to put in the first digit? I could put 2, 3, or 5. So I have 3 choices for the second digit. And for this digit here, I've chosen 2 out of the 5 that are available, so I have 3 left. So there we go. Okay, so here I've chosen the 2, so for this last digit. So what choices do I have for the first digit? I can use 3, 4, or 5, so I have 3 choices again. And again, I've chosen 2 out of the 5, so I have 3 left. All right, odd integers from 10 through 99 that have distinct digits. Okay, odd, so that means that I have 5 choices for the last digit, 1, 3, 5, 7, 9, right? So there's 5 choices here. And distinct digits, whatever I chose here, I cannot choose here. And it can't be 0. Can't be 0 or the other digit, right? Can't be 0 or this digit here. So that means I only have 8 choices there. All right, I've got a club with 6 men and 7 women. How many ways can I choose a committee of 4 persons where there's at most 1 man? So at most 1 man means no man or 1 man. Okay, so if there's no man chosen out of the, I'm choosing a committee of 4 out of the out of no man chosen, out of the 7 women, I'm choosing 4 of those, right? Because I'm choosing 4 from the women. If I'm choosing 1 man out of the 7 women, I'm choosing only I'm choosing 3 women, and out of the 6 men, I'm choosing 1. All right, how many different ways can I arrange this so that the string contains D, E, F? So that means I'm carrying this along as one entity. So really I have 4 things to move around. 1, 2, 3, 4. So 4 things to rearrange is just going to be 4 factorial. Just finding different arrangements. Because once I choose the first one, if I choose A, put A down, so that's one of the 4 choices of the letters. Then next I have 3 choices left, and then I have 2 choices, and then 1. That's 4 factorial. All right, so I've got 50 phones, and I know 4 are defective. How many ways can I pick exactly 2 defective phones when I'm picking out 4? So out of the 4 that are defective, I want to pick those 2, or 2 out of those 4, I should say. And out of the, it's not 50 phones, because I know 4 are defective, so it's really out of the other 46 that I pick the other 2. So these 2 give me the 4 phones total that I'm choosing. 8 different kinds of batteries. Oh, kinds of batteries. Lots of different kinds of batteries. That tells me categories. So that tells me stars and bars. All right, so if I have 8 different kinds of batteries, I need 7 bars to separate the 8 kinds of batteries, right? So how many ways can I select 30 different kinds of batteries? So I'm going to be choosing 30. Be choosing 30 from 30 plus the 7 bars. All right, how many different selections of 30 batteries if I have to for sure choose 4 that are AAA? So I'm not choosing 30 anymore, I'm choosing 26. And I'm choosing 26 out of the 26 plus the 7 bars.